Hello, my name is Shane Haladuick from ASARC at the University of Calgary, and this presentation is going to compare the use of field observations and snowpack tests by recreational skiers. For the motivation behind this study, I'm going to use an example. So this is showing the regional bulletins in Western Canada. And let's say we take a hypothetical day in the middle of the winter last year and we look at just the tree line bulletins. We're going to have variability, and this variability is variability at the mountain range scale. So maybe we have some moderate dangers up in the north, it's considerable here in the Columbias, and then we have low at the coast and in the South Rockies. If we zoom in to look at just the North Columbia Caribou region here, which is about 30,000 square kilometers, we're calling the danger considerable at treeline on this day. But let's say that last night a storm came in, and it came in from the west and over the north of this region. This storm's going to bring varying amounts of snow and precip to the region, and that's going to cause the danger to be variable throughout this region. So even though the danger is called considerable for the whole Caribou region, in reality there's going to be these pockets where there's higher danger and lower danger, depending on the preceding events. And this matters a lot when you go and you take a skier and put a skier on this slope. This skier needs to be thinking about what the danger is right here and right now where they're skiing. And this is what we're terming the local nowcast, which is as opposed to the regional forecast for the whole Caribou region. There are two main differences. There's the spatial difference, which is where in that region are they, and then there's the temporal difference. That regional bulletin was based on a forecast. Did that forecast come true? And these lead to two questions that the skier needs to be asking themselves. Is it still considerable in this area where I'm skiing at treeline, and how do I know? We know by using information. And there are two types of information we identified in this study. There are these non-digging field observations, everything we can do without digging into the snowpack, and then there are our snow profiles and our snowpack tests. And in this study we're going to be comparing which of these two types of information has more value to recreational skiers. So how did we do this study? A typical field day for this study replicates a recreational backcountry ski day. So we start at the trailhead below tree line, and we ascend up through the trees either on skis or a snowmobile. And along the way we're making these field observations, these non-digging observations. We stop a couple times to make a quick hand shear and a ski pole probe. And we work our way up to what we're calling the decision point. And that's the point at which our team is deciding whether or not we want to enter more hazardous avalanche terrain for the day. So this is McGill Shoulder here at Rogers Pass. And maybe we're deciding whether or not we want to continue up this ridge and ski these two primary avalanche chutes, or if we want to stay over here and ski these sparse trees. We do a few things at the decision point. First, we identify the main avalanche problems of the day. And this is from a list very similar to what's used in the bulletins by the Canadian Avalanche Centre. Then we rate the local danger for the day, and this is the danger rating for just McGill Shoulder, just on this day. And we rate it using all the information available to us to try to make the best rating that we can. After we rate the danger, we perform our snowpack tests and our snow profile for the day, typically at the decision point. And then we descend back towards the trailhead, again making our field observations along the way. When we get back to the trailhead, we rate the local danger one more time. This list shows the field observations we're looking at in this study. There are 26 field observations we were taking. Typical things that you learn in intro avalanche courses, such as avalanche activity, WUMFs, a lot of measures of new snowfall, and etc. The snowpack tests we were looking at, there were two of them. We were looking at the compression test and the ruche block test. We chose these tests because we were looking at stability tests that test the entire snowpack, and also we were looking for tests that are commonly used by recreationists. So the compression test is used frequently in North America, and the ruche block test is used frequently in Europe. This graph shows the data set that we collected during this study. We have a total of 425 field days on which we did the field observations. We have 295 days with CT tests and 93 days with ruche block tests. And you'll see the breakup here by the avalanche character that we identified. So a lot of days with storm, persistent, and wind slab, less days with the other characters. So there are two statistical approaches we used in this study, both a univariate approach and a multivariate approach. And I'm going to be talking specifically about the use of classification trees in the multivariate approach. So first of all, what are classification trees? This is an example of one here, and I'm going to use it to describe how it works. So the first thing that's important to notice is that they take these observations and they point them down at the danger. And they do this by looking at the relationships between the data. So they're looking at two forms of the relationships. First, they're looking at all the ways that the branches can be ordered in the tree. So essentially, the rank of these that the observations are selected at, the higher that they're selected in the tree, the more important the observation is. And then the second thing they're looking at is the critical values that the observations split on. So every observation is split into not critical and more critical. So for instance, HN48 of 13 centimeters or more is critical. Ski penetration of 28 centimeters or more is critical. The way that they determine these relationships is by always making the step that minimizes the cost of forecasting the danger wrong. So this is very similar to maximizing the number of times the tree is correct, the percentage correct here. So for this tree, for storm slab, this tree is right 68% of the time. 68% of the time that you give this tree this information, it will predict the danger correctly compared to what we predicted the danger in the field. And it's also important to note that this percentage correct is cross-validated, which means that if you give this tree information from a day from next winter, it should be just as accurate as it was from the information we gave it from last winter. And then finally, we simplified this tree by breaking the danger into just low to moderate or considerable or higher. And that's just so that it's easier to interpret. Final thing to note when thinking about these trees is that these trees are objectively built, which means that I didn't have any input into how the tree was formed. This tree is formed automatically using an algorithm based on our data. So we can use these classification trees to compare the value of field observations to snowpack tests for recreationists. And we do this by comparing two classification trees. So first we built a classification tree using only field observations, and then we built another classification tree using both the field observations and the stability test variables. So I'll use an example here. This is the classification tree for storm slab, and this is built using only the field observations. And I'll draw your attention to the blowing snow variable down here in the corner. This is the classification tree for storm slab built using both the field observations and the stability test variables. And you'll see that the only change was that blowing snow was replaced by RBW, which is the lowest Roosh block score for a whole release. And so if you remember the important things about classification trees, there were two things. The first is the frequency of the variables selected. So you'll see that there are 5 variables selected by this tree. 1, 2, 3, 4, 5. And only one of these 5 is a stability test variable. And then the second thing you'll notice is the rank of where those variables are selected. So if you remember, the higher in the tree, the more important those variables are. This only sole stability test variable was selected in the lowest rank of this tree. And that's what we found consistently. So for all of the avalanche characters, we found that they were selecting many more field observations than stability test variables, and that the field observations were being selected higher in the tree. And we were also able to confirm this with the univariate analysis, also showed this. So our conclusion from both of these analysis types was that for recreationists, there's not a lot of information available in these stability tests that they can't get from other sources like these field observations. Thank you very much for listening, and I'd like to thank my sponsors for this research.